Hello everybody, I am very saddened to announce that today, this video will be our last video for the renewable energy PowerPoint playlist, selection, whatever you want to call it. So, without further ado, let's get on with our last little bit of notes here on geothermal energy. Yes, that's right, geothermal energy. So, what is geothermal energy? Well, think about it. Geo means what? Very good. Earth. Thermal means what? Excellent. Temperature, warmth, right? So we're going to be using the warmth of the Earth as energy. Let's move on and figure this out. Geothermal uses Earth's internal heat or steam from underground to run a turbine. 17 geothermal sites in the US and out west. The disadvantages, as always, you need to know that there are advantages as well as disadvantages, okay? Disadvantages would be H2S gas, hydrogen sulfide, air pollution. We get that from the release when we when we agitate the earth, as well as the types of chemicals that are being used. Substance as water is depleted because we're using a high degree of water in this, and it's also very corrosive to the pipes because the chemicals that we are using. How does geothermal work? That's basically, you're essentially setting up a radiator. And if you know, a radiator has a pipe that goes through in a like accordion fashion, okay? And it circulates water or another type of compound through there. Maybe it could be antifreeze, water, something along those lines. The goal here is to try and get as much surface area, as much water, a larger volume in a smaller area. So that's why we circle up and down and we compress it, kind of like an accordion. Oh goodness, I don't think I have anything, but think about it this way. If you were to take a line and just bring it right through here, right? There's our barriers. If we were to heat a certain area, we're only heating this line right here. But now what if we bring it through? We bring our line and now we're gonna go up and down. And now we bring it through. Which area will be warmer? I realize it's kind of small. I should really stop this. Let's do a stop share and bring it up to the major part. Which one is gonna get warmer quicker? The answer is this one right here. Why? Because there's more area, there's more volume in that warming section than there is with this small one. I kind of feel like a news person. Hello guys, you can see that there's more warming in this area than there is in the upper area. The reason being is because there is a larger volume of water that is traveling through, not to be confused with the smaller volume that is moving through the top. Tomorrow we'll be expecting rain with a chance of sun. I'm just kidding. But this is why we have this radiator type fashion. And you guys just saw that in the last PowerPoint slide. Okay? Let's bring that back up there. All right, so here we are again. We see that radiator type fashion right down here on the bottom. Okay? Hopefully that helped to visualize why we try and cram all those loops in one small area. Let's see. So how does this work? Well, the ground is always a very consistent temperature, around maybe 40 degrees Fahrenheit. So that being said, in the winter, it's warmer than the air temperature. In the summer, it's cooler in the air temperature. We could use this as a heat and reverse heat pump. We could warm our house in the winter because the ground is warmer. We can cool our house by drawing the heat out in the summer because the ground is cooler. Geothermal heat pump, 50 degrees at 8 feet down. Okay, so roughly 50 degrees if you go 8 feet down into the ground. Cools in the summer, warms in the winter. This heat pump is taking this ambient temperature, this consistent temperature, and bringing it into this box right here. And from this box, it can be diverted into a water heater, or it can be diverted into a heating system for a home. So we could use that as a type of a crutch, an aid for our water heater, just like we had. Do you remember back when we talked about passive solar design and we had the water heaters up on the roof, right? We circled the water through there and we said, well, that's not heating the water 100%, but it's aiding our water heater. It's bringing the water temperature up so the water heater doesn't have to work as hard. Same idea as this. It's bringing the water temperature up so the water heater doesn't have to work as hard, okay? With regard to the heating system, that works both ways, right? In the winter, the warmer ground temperature will bring that water temperature up and it won't have to work as hard to heat the water if you have water baseboards, right? Fluid baseboards. In the winter now, in the summer, it'll suck the heat out and it will cool the area because that cooler water we can have as it circulates through. We have a fan blowing over and it blows that cooler air from the cooler water out through your vents. I promise I will link some videos up here. Let's see, moving on, geothermal. Not only is this a personal use energy source, but it is also industrial use energy source. Similar to the way you can have solar panels on your roof, or you can have a giant solar farm. Okay, so this is just a little diagram of how a geothermal power plant works. Again, I want you to see the same idea. We're using heat, water to steam, steam turbine, turbine generator, generator makes electricity. Moving on, geothermal energy. Deeper, more concentrated hydrothermal reservoirs can be used to heat homes and buildings and spin turbines. There is a dry system in which we use water vapor with no water droplets, and there's a wet system, which is a mixture of steam and water droplets. That's the way we're turning or heating, turning the turbine or heating something to turn the turbine, usually water. Hot water is trapped in a fractured and porous rock. We need to release that. Releasing that energy is what allows the water to move up, turn to steam. Moving on, we see again a residential use. The neat thing with this is you can either go down, or if you live by a lake, as I do, you can go down and out under the lake. The lake keeps a very consistent temperature right underneath of it. So there are multiple avenues as far as getting your geothermal system hooked up. Continuing to move on, we are almost done there, guys. This is our last slide. As always, the advantages and disadvantages of a geothermal system. As with any other renewable system, advantages, very high and efficient, lower CO2 emissions, a low land use. Think about it, it's all underground. Moderate, not a huge, but a moderate environmental impact, which when compared to mining or other fossil fuels, it's very good. Disadvantages, though, we need to think of depleted if it's used too rapidly. The CO2 emissions that do come from drilling. And what damage are you doing when you're drilling? Noise and odor, maybe the cost. It's quite expensive to do this, especially for residential uses. So I want you to look for the videos. You know, they're somewhere around all of these spots. They might even be over my face at the very end. Who knows? But I want you to take a watch at those videos. Enjoy this. I want you guys to study up. The next thing we're going to be doing is make sure you all read up in the chapter. You have all the CP questions done. Make sure you have those end of chapter FRQs and multiple choice questions done. And we will be looking for our chapter 13 test to come out pretty soon. Guys, have a great day. Remember, if you have any questions, email me. And I will see you all in the next installment of As the PHS Turns. What will happen next? Will he drink from a water jug? Will this weird little unicorn pen work? Will he start to show you his mug collection? This one, by the way, is a Rhode Island mug collection. Very cool. Who knows? Stay tuned to find out. Take care, guys. Bye.